Welcome. Uh, Today we are going to simulate a control circuit and a power circuit for a motor starter, a three-phase induction motor starter. Basically, this is a starter for small motors, those motors that do not require, demand huge amounts of currents. Because basically a forward and reverse motor starter, it's a DOL, it's a direct online motor starter, and the DOLs are applied in areas where our current or the current that is being consumed by the motor is not huge. It's not huge, so it is used for starting small motors. So we have in our circuit, we have the power circuit. The power circuit here, it's composed of this circuit breaker, 4-pole circuit breaker, these two contactors, contactor 1, contactor 2. It is composed of the thermal overload relay and the motor itself. So aside from that, we have our control circuit. Our control circuit basically is used to control these contactors, to control the turning on and turning off of these contactors, so that our motor may go into operation. So we have the coils. This is the coil for contactor 1, this is the coil for contactor 2. We have our indicator lamps to show us that power is available. We have our start push buttons, stop push buttons right here, and we have our normally open contacts for contactor 1 and contactor 2. This normally open contact, this one and the other one, they are used to provide holding contacts, such that when we press our start push button, it will remain on until we press the stop push button. So we have the holding contacts right here. We also have the electrical interlocks. So these interlocks are used to help us protect our circuit, to protect our motor against short circuit. As you can see, for us to change directions here, we have connected different phases together right here. So the moment if we do not have this electrical interlocks and we start this motor using this control circuit, and at the same time we use the other one, our motor is going to it will go into a condition of short circuiting, destroying our motor, destroying our instruments right here. So we have the interlocks with us. So let us simulate, let us pray as for us to observe how our motor is operating. So we need to turn on the circuit breaker. As you can see, power is available. It's available at the top of the contactors right here. So we need to turn on this contactor so that it can allow power to flow into our motor. So, and for us to control or to turn on these contactors, maybe for the forward contactor, contactor 1, we need to press the start push button right here. As you can see, the moment we pressed, power began to flow and the motor is running in the forward direction. Our indicator lamps is showing us that power is flowing, so our motor is running in the clockwise directions. So for us to stop this motor, just press the stop push button and you can see the motor is off. When we start, we press it to turn it on. If we press or we disconnect our start push button, as you can see, the motor is still running. It is still running, showing that our holding contacts keep the current flowing. They keep the current flowing. So we stop the motor. Then let us test for the reverse direction. So the moment we press the second start push button, as you can see, power is available. It is flowing through the other circuit, through the second contactor. Be keen on that. So it is flowing through the second contactor. Power is available. Our indicator arms shows that when we press the stop push button, the motor goes off. It stops. Pushing it right again, it goes on. Yeah, so this basically shows the working of forward and reverse motor starter. As we said, it is applied in small motors, whereby we do not require, or our motor doesn't require huge amounts of current, basically because forward and reverse starter, it's a DOL, and DOLs are used for small motors. They are used for small motors. So that is the working of our circuits. It is applied in industries. When you go to industries, you will find these motors being applied where there is need for change in directions. So they are applied in such circumstances. Thank you for tuning in. Yeah, thank you.